Welcome to today's lecture. So, in our last lecture, we had started with unit number 3, that is kinematics of fluid flow. We had seen the definition of fluid kinematics. It is a branch of fluid mechanics which deals with the study of fluid in motion without considering the forces acting on it. Okay. Then we had seen the method of analysis of fluid flow motion. There are two methods. First is Laminar method, second is Eulerian method. In Laminar method, a single fluid particle is taken into consideration for study, and the different properties such as velocity, acceleration, density is determined, and it is assumed as the property of entire fluid flow. Okay, it is not an accurate method. And second is Eulerian method. So in Eulerian method, a particular point in space, okay, which can be a control space or control volume. So that is taken into consideration, and study is made on all the different fluid particles entering and leaving the control volume. Okay, and the properties are determined, and that is assumed as the property of entire fluid.
Okay, so in Lagrangian method, a single fluid particle is taken into consideration, and study is made only on the single fluid particle, and it is assumed as the property of entire fluid. Okay, while in Eulerian method, a point in space, that is control volume or controls, that is considered, and number of fluid particles entering and leaving that control volume, and study is made on all the fluid particle entering and leaving. Okay, so Eulerian method is more correct method. Okay, and we had seen the classification of fluid flow. So fluids are classified as steady and unsteady flow. Okay, so here time is the criteria. आपको time याद रखना है कि steady and unsteady flow में criteria क्या है? Time. So in steady flow, it is a type of flow in which any of the properties such as velocity, acceleration, density, etc. does not change with respect to time. And that type of flow is called as steady flow. And in unsteady flow, if any one of the properties such as velocity, pressure, density, etc. changes with respect to time, then the type of flow is called as unsteady flow. Okay. After that, uniform and non-uniform flow. So uniform flow is simply defined as a type of flow in which the velocity at any given instant of time does not change with respect to position. Okay, that means along x direction, if you take any point, or along y direction, if you take any point, so the properties remain changed. So पूरे cross section area पे जो velocity रहेगा वो constant रहेगा. Okay, in uniform flow. In non-uniform flow, the velocity at any given instant of time changes with respect to position. Okay, so that type of flow is non-uniform flow. Then next is laminar and turbulent flow. So laminar flow is a type of systematic flow in which all the fluid particle travels in a systematic manner, and the flow takes place in number of sheets or laminates gliding over each other. Okay, so such type of flow is called as laminar flow. And turbulent flow is a type of flow, unsystematic flow, in which the fluid particle behaves in unsystematic or undisciplined manner. Okay, and in turbulent flow, cross current, eddies, these are formed. So that type of flow is turbulent flow. So for the case of flow through pipe, there is one dimensionless number which determines whether the flow is laminar or turbulent. So that is called as Reynolds number. So Reynolds number is defined as the ratio of inertia force to viscous force. So if the value of Reynolds number is less than 2000 for flow through pipe, then it is laminar flow. If Reynolds number is more than 4000, so it is turbulent flow. And if it is greater than 2000 but less than 4000, then the flow can be laminar or turbulent, and it is called as transition flow. Okay. The next is compressible and incompressible flow. So compressible flow is a type of flow in which the density and hence volume, okay, of the fluid does not change with respect to time, okay, or does not change during the fluid flow. Okay, that means in the direction of flow, the density of the fluid always remains constant. So that type of flow is called as incompressible flow. And compressible flow is a type of flow in which the density and hence the volume of the fluid continuously changes in the direction of flow. So that type of flow is compressible flow. After that, next is rotational and irrotational flow. So rotational flow is a type of flow in which the fluid particle, while traveling along the fluid path, also rotate about its mass center. Okay, so that type of flow is called as rotational flow. So for example, Earth rotates around the sun, revolve around the sun, it is also rotating about its own axis. Okay, so can say the motion of Earth around the Sun, it is a type of rotational flow. In irrotational flow, if during the flow path the fluid particle does not rotate about its own mass center, then the type of flow is called as irrotational flow. Okay. After that, we had seen some basic definitions. It deals with kinematics. So first is path line. So path line is actual path traced by fluid particle during the fluid flow. Okay. So जो actual fluid particle का path है, so that line is called as path line. Then streamline. Streamline is simply defined as an imaginary line drawn from the flowing mass of fluid such that tangent drawn at any point represent the direction of velocity vector at that point. Okay. And strict line is nothing but it is a resultant line formed by number of path line. Okay. Passing through a given point in a fixed duration of time. Okay, that is called a strict line. And stream tube is nothing but tubular space formed by joining number of streamlines. I think all this we had seen in our last lecture. Then we had seen discharge. Discharge is nothing but it is a rate of flow of water, or simply defined as volume of water flowing in a given span of time. So it is volume upon time. It is also given as the product of area into velocity of flow. Okay, and I think we had also seen the continuity equation. Okay, so continuity equation for one-dimensional fluid flow. Okay, so this continuity equation is dependent on the law of conservation of mass. Okay, which states mass flow rate into the system that equals to mass flow rate out of the system. Therefore, rate of flow at section 1 that should be equals to rate of flow at section 2. Okay, therefore rho 1 A1 V1 that equals to rho 2 A2 V2. So this is nothing but continuity equation. Now it is applicable for compressible as well as incompressible fluid flow. But for incompressible fluid flow, okay, this density is always constant. Okay, अभी हमने definition देखा है ना कि incompressible flow is a type of flow in which density and hence volume of the fluid does not change. Therefore, density of inlet it should be equals to density at outlet. So rho 1 equals to rho 2. So cancelling rho 1 rho 2. So for incompressible fluid flow we will have A1 V1 equals to A2 V2. Okay. And this product of A and V is nothing but discharge. So discharge at inlet it should be equals to discharge at outlet. Okay. So I think all this part we had covered in our last lecture. Okay. So today we are going to see one numerical on the continuity equation. Okay. So first numerical, a 30 centimeter diameter pipe, a 30 centimeter diameter pipe conveying water, 30 centimeter 30 centimeter diameter pipe conveying water branches into two pipes of diameter 20 centimeter and 15 centimeter respectively. Branches into two pipes of diameter 20 centimeter and 15 centimeter respectively. If the average velocity in 30 centimeter diameter pipe, if the average velocity in the 30 centimeter diameter pipe is 2.5 meter per second, find the discharge in the pipe. Also determine the velocity in 15 centimeter diameter pipe. If the average velocity in 20 centimeter diameter pipe, is 2 meter per second. Okay. So solution. First of all, what is given? A 30 centimeter diameter pipe. So this is a pipe of diameter 30 centimeter or 0.3 meter. Branches into two pipes. So it's going to branch itself into two pipes. Okay. The diameter of one pipe is 20 centimeter. That means 0.2 meter. And other is 15 centimeters. So 0.15 for D1 square. So pi by 4 0.3 square. So it is 0.07068 meter square. Then V1 is 2.5 given. Okay. D2 is 20 centimeters. So it is pi by 4.2 square. So it is 0.0314 meter square. V2 is also given 2 meter per second. Then D3 is 0.15 meter. So it is A3 is pi by 4 D3 square. So pi by 4 0.15 square. So 0.01767 meter square. Okay. Now we are supposed to calculate discharge in pipe 1 and velocity in pipe 3. So we know we will select Q1, Q2 and Q3. These are the discharge in pipe 1, 2 and 3 respectively. Okay. So according to continuity equation, whatever the discharge at inlet, it should be equals to discharge at outlet. But outlet has two pipes, pipe 2 and pipe 3. Okay. Therefore, inlet discharge Q1, it should be equals to addition of outlet discharge Q2 plus Q3. Okay. Therefore, first of all, we will find the discharge in pipe 1. So pipe 1, Q1 is nothing but A1 into V1. So pi by 4 D1 square, okay, which is 0.07068 into 2.5. Okay, so it is 0.1767 meter cube per second. After that, we are supposed to find the velocity V3. So we know discharge Q2. Q2 is again A2 into V2. So 0.0314 into 2. So it is 0.0628 meters cube per second. So we'll put the value of Q1 and Q2. Okay. So we will have 0.1767 equals to 0.0628 plus Q3. So transfer this on right side and do the subtraction. Okay. So Q3 is 0.1139 meter cube per second. Now this Q3 is nothing but A3 into V3. Okay. So put the value Q3 is nothing but A3 into V3. So put the value of A3. Okay. After that, put the value of Q3 also. Then divide this A3 to Q3. So we will get the velocity V3. So V3 comes out to be 6.44 meter per second. Okay. So very simple numerical. You can solve any such type of numerical. Okay. Then next is continuity equation for three-dimensional fluid flow. Okay. So consider any fluid element in the shape of parallelepiped. Okay. As shown in the figure of dimension dx, dy and dz. Okay. So हमने कोई भी parallelepiped की shape में fluid particle assume किया and the dimension of fluid particle are dx, dy and dz along x, y and z direction respectively. Let small u, small v and small w, these are also the component of velocity in x, y and z direction. Okay. After that we will this parallelepiped, it will have 8 corners. Okay. So we will name them this corner. Let A, B, C and D. This is the leftmost corner and E, F, G, H. Okay. This is the rightmost corner. Okay. So ABCD is the leftmost corner and EFGH is the rightmost corner. 1 minute waiting like. Okay. So ABCD, it is the leftmost corner and EFGH, it is the rightmost corner. Okay. So first of all, we will find out whatever the mass flow rate entering the system. Okay. Now we will assume that along x direction, the flow will take place in this direction. Okay. So fluid will enter in x direction along face ABCD and it will leave along face EFGH. Similarly, along y direction, fluid will be entering from lower face and it will be leaving from upper face. Along z direction, we will say it will be entering from this end and it will be leaving in this direction along y direction. Okay. So first of all, we will talk about x direction. So in x direction, the mass of fluid entering through face ABCD. Okay. So we know mass flow rate is nothing but density into area into velocity. Okay. So density of the fluid, we will say assume it is rho. Okay. Then area of ABCD. Okay. Into velocity in x direction. So velocity in x direction is u. So it is rho into u into area ABCD. Now area ABCD is nothing but this length is dy. Okay. This length is dy. Sorry, this length is dy. This length is dy and this length is dz. Okay. So area is nothing but dy into dz. Okay. So it is rho into u into dy dz. This is the mass flow rate entering the system. Similarly, mass of fluid leaving the system. Okay. Mass of fluid leaving the system. Now we know what is our sorry. 1 minute, sorry. Okay, now we know what is our law of conservation of mass. Law of conservation of mass is mass flow rate mass flow rate outlet minus inlet. Mass flow rate outlet minus mass flow rate inlet, that should be equals to rate of change of mass. Okay, dm by dt. I think ये हमने last time भी discuss किया था. ओके, सपोज कोई भी पाइप है या फिर कोई भी आपका फ्लूइड फ्लो सिस्टम है, सपोज 1 kg पर मीटर और 1 मीटर क्यूब पर सेकेंड। ओके, ये उसका मास फ्लो रेट इन है और 1 kg पर सेकेंड ये मास फ्लो रेट इन है, एंड 1.5 kg पर सेकेंड ये उसका मास फ्लो रेट आउट है। तो इन दोनों का डिफरेंस जो है 1.5 माइनस 1, तो ये मास फ्लो रेट कितना होगा, ये एक्सटर्नली ऐड होगा, ओके, जनरेट होगा। सिमिलरली इनलेट पे 1 है और आउटलेट पे 0.5 है, 0.5 माइनस 1 मतलब माइनस 0.5, so negative sign it will indicate some mass is consumed. Okay, so similarly, so we will have mass flow rate out minus mass flow rate 8 is nothing but rate of change. Okay, therefore we can say mass flow rate out of the system m dot o is nothing but transfer this right side, so it will be mass flow rate into the system, okay, plus rate of change in x direction, so it will be dm dot by dx. ओके, dm डॉट बाय dx। अभी एक्चुअली हमारे केस में पार्शियल डिफरेंशिएशन होगा, बिकॉज y डायरेक्शन में भी चेंज होगा, z डायरेक्शन में भी चेंज होगा और x डायरेक्शन में भी चेंज होगा। तो हम ये dm डॉट को ऐसा लिख सकते हैं, इट इज m डॉट इन, ओके, प्लस डेल्टा m। ओके, हम कंप्लीट डिफरेंशिएशन के वजह पार्शियल डिफरेंशिएशन ले रहे हैं, सो इट विल बी m डॉट इन डेल ऑफ m डॉट इन अपॉन डेल x, ओके, इनटू dx। ओके, तो हमने क्या किया, कंप्लीट डिफरेंशिएशन को पार्शियल डिफरेंशिएशन में कन्वर्ट कर दिया। सो इट विल बी m डॉट इन, सो m डॉट इन कितना था, रो u डिवाइड dz। ओके, सो इट इज मास फ्लो रेट इन रो u डिवाइड dz प्लस रेट ऑफ चेंज इन x डायरेक्शन, और उसमें हम पार्शियल लेंगे बिकॉज y और z डायरेक्शन में चेंज हो रहा है। सो इट विल बी del del x of m is rho u divide z inlet, okay, into dx. So is this understood how the outlet mass flow rate is calculated? So outlet mass flow rate is nothing but inlet mass flow rate plus rate of change of inlet mass flow rate in x direction. So it will be m dot in plus del del x of m dot in into dx. So it is rho u divide dz plus del del x of rho u divide dz into dx. Okay, so this is mass flow rate out of the system through phase EFGH. Okay, therefore rate of change of mass flow rate or gain of mass, okay, so that equals to mass flow rate in minus mass flow rate out. Okay, so that equals to rho u divide dz minus of rho u divide dz plus del del x of rho u divide dz into dx. Okay, so negative sign यहाँ पे हम ओपन करेंगे, so ये नेगेटिव हो जाएगा, so it is minus rho u divide dz minus of del del x of rho u divide dz. Okay, so this minus rho u divide dz minus rho u divide dz, it will cancel, so we will have minus of del del x of rho u divide dz, okay, whole into dx. Okay, now here rho, what is rho? Rho is mass density of the fluid. Okay, and suppose water है तो 1000 रहेगा, मर्क्यूरी है तो 13600 रहेगा, so it is constant. तो आप इसको डिफरेंशिएशन के बाद जा सकते हो। Then what is dy dz? dy dz is also dimension. Okay, आपने एक बार एरिया सिलेक्ट कर लिया, dy dz का वैल्यू चेंज नहीं हो सकता है, so it is also constant. Okay, sorry, यहाँ पे dy dz जो है ये constant है, okay, because they are dimension, so we will take that outside. Okay, so we will have minus del del x of rho u dx dy dz. Okay, यहाँ पे रो हम कब कांस्टेंट ले सकते हैं, जब इनकम्प्रेसिबल फ्लो हो। कंप्रेसिबल फ्लो है तो रो कांस्टेंट नहीं रहती। okay, so अभी हमने बाहर नहीं लिया है, so it is minus of del del x of rho u dx dy dz. So this is the gain of mass in x direction. Similarly, gain of mass, net gain of mass in y direction. So similarly, y direction में क्या रहेगा, it will be del del y into minus of del del y of rho into v. V is nothing but velocity in y direction. Okay, into dx dy dz. Similarly, net gain of mass in z direction, it will be minus of del del z of rho into w. W is nothing but component of velocity in z direction into dx dy dz. Okay, so x डायरेक्शन में इतना गेन हो रहा है, y डायरेक्शन में इतना गेन हो रहा है, z डायरेक्शन में इतना गेन हो रहा है, so total gain कितना हो रहा है, it will be the sum of all these three. Okay, therefore net gain of masses, it will be minus sign common ले लिया, so it will be del del x of rho u plus del del y of rho v plus del del z of rho w bracket complete. Again dx dy dz कॉमन था तो हमने कॉमन ले लिया. Okay, so it is minus of del del x of rho u plus del del y of rho v plus del del w of rho w del del z of rho w bracket complete dx dy dz. Okay, so this is gain of mass. But ये gain of mass कब हो रहा है? Okay, ये gain of mass हो रहा है for a particular time t. Okay, ये कितना, ये जो भी गेन हुआ ये कब हुआ? जब फ्लूइड फ्लो जो है वो पर्टिकुलर कंट्रोल वॉल्यूम से या फ्लूइड पार्टिकल का जो स्पेस है जो हमने अज्यूम किया है वो स्पेस से टाइम के लिए पास हो रहा है. ओके, देयरफॉर as per the law of conservation of mass can neither be created nor destroyed. Therefore net increase of mass, okay, per unit time must be equal to rate of increase. जितना given time t में mass increase हुआ है, it should be equals to total gain of mass. Okay, so basically we will equate this with rate of change of mass with respect to time. Okay, now we know हमारा mass क्या होता है, 1 minute, density क्या होता है? Density is mass upon volume. Okay, so mass is nothing but density into volume. Density into volume. अभी ये पर्टिकुलर ऊपर का जो क्यूबिकल बॉडी था उसका वॉल्यूम क्या था? उसका लेंथ dx था, हाइट dz था और विड्थ dy था. ओके, सो इट इज रो इनटू dx dy dz, dx dy and dz. ओके, सो मास इज नथिंग बट रो इनटू dx dy dz और उसका हम डिफरेंशिएशन करेंगे विद रिस्पेक्ट टू टाइम t. ओके, so it will be del del t of rho dx dy dz. Okay, therefore rate of increase of mass in time t is rho del rho by del del t of rho into dx dy dz. Now this dx dy dz are dimension, so it can be taken outside. So it is del rho by del t into dx dy dz. Okay, so we will equate this rate of change of mass with respect to time with net gain of mass along x, y and z direction. Okay, so therefore equating the two expression we will have minus of del del x of rho u plus del del y of rho v plus del del w of rho w into dx dy dz, that equals to del rho by del t into dx dy dz. So dx dy dz cancels from both side. Okay, and ये जो negative sign है इसको आप right side में ले जाओ. So finally you will have plus del rho by del t plus del del x of rho u plus del del y of rho v plus del del w of rho w, that equals to 0. Okay, so cancelling dx dy dz from both sides. Now the above equation is called as continuity equation. This is also one form of continuity equation, and here rho is not constant. Okay, so this is applicable for compressible flow. आप compressible flow को ये equation apply कर सकते हो. Okay, but for incompressible flow, okay, अभी यहाँ पे actually हम कुछ special cases देखेंगे, which is study unstudy, uniform non-uniform and compressible incompressible. ये cases check करेंगे. तो first of all study flow. So study flow क्या होता है? Study flow is a type of flow in which the properties are not changing with respect to time. Okay, that means in study flow टाइम कांस्टेंट टाइम के साथ प्रॉपर्टी चेंज नहीं होनी चाहिए. दैट मींस डेल रो बाय डेल टी. ओके, डेल रो बाय डेल टी होना चाहिए? 0 होना चाहिए, बिकॉज डेंसिटी इज नॉट चेंजिंग विद रिस्पेक्ट टू टाइम. ओके, सो फॉर स्टडी फ्लो दिस डेल रो बाय डेल टी that should be equals to 0. Okay, so we'll put in equation. So equation will become del del x of rho u plus del del y of rho v plus del del z of rho w equals to 0. So this is continuity equation applicable to steady flow. Okay, steady compressible flow, ये steady compressible flow को apply हो सकता है. Okay, again if fluid is incompressible, fluid को हमने incompressible assume किया, तो basically उस केस में density constant हो जाएगा. Okay, so if density is constant तो आप इसको differentiation के बाहर ले जा सकते हो. So यहाँ पे रो del x del u by del x हो जाएगा प्लस रो del v by del y प्लस रो del w by del z और रो को हम डिवाइड कर देंगे टू 0. ओके, तो हमारा इक्वेशन बन जाएगा सिंपली del u by del x plus del v by del y plus del w by del z equals to 0. Okay, so this equation is the most generalized form of continuity equation and it is applicable to incompressible स्टडी फ्लो, बिकॉज यहाँ पे हमने डेंसिटी कांस्टेंट अज्यूम किया है, अजम्पशन आपको याद होनी चाहिए। यहाँ पे आपने डेंसिटी अज्यूम की है, दैट मींस फ्लो कौन सा रहेगा, इनकम्प्रेसिबल फ्लो। और यहाँ पे आपने टाइम के साथ डेंसिटी को कांस्टेंट अज्यूम किया था, तो यहाँ पे स्टडी फ्लो रहेगा। ओके, नाउ सपोज टू डायमेंशनल फ्लो है। So two dimensional flow में क्या होता है, properties net changing in third direction. Okay, so in third direction W will be 0. Okay, so for two dimensional fluid flow W will be 0, therefore equation can be reduced to del U by del X equals to del V by del Y. Okay, so these are this is the form of three-dimensional continuity equation, and this is the form of two-dimensional continuity equation. Okay, and what why continuity equation is important, because continuity equation satisfy हो रहा है। इसका मतलब क्या satisfy हो रहा है, law of conservation of mass, because continuity equation कहाँ से define हुआ है, derive law of conservation of mass. Okay, so if continuity equation is satisfied, so basically law of conservation of mass is satisfied, therefore fluid flow, okay, flow will exist। जो आप बोल रहे हो कि ये जो कोई भी मैथमेटिकल इक्वेशन दिया होता है आपको, आगे हम जो प्रॉब्लम देखेंगे उसमें एक मैथमेटिकल इक्वेशन दिया होगा फ्लो के लिए, और हमें चेक करना रहता है फ्लो होगा कि नहीं। तो फ्लो होगा कि नहीं कैसे चेक करेंगे, आप उसका डिफरेंशिएशन करेंगे u कंपोनेंट का विद x, v कंपोनेंट का विद y एंड w कंपोनेंट का विद z, और तीनों को एडिशन करेंगे, एंड इफ दैट इज इक्वल्स टू 0, then the flow will take place. Okay, or it will be the condition for fluid to take place, flow to take place. Okay, remember continuity equation is very important equation.